Welcome again to Rogo's Daily Facts, where we delve into another video about the awesomeness of space. Have you ever pondered the idea of generating power from the coldness of deep space? A question that might seem like it's straight out of a sci-fi novel, but it's not. It's a concept that's very much grounded in reality, and it's being explored right now. Today we generate power in a myriad of ways. We burn fossil fuels, harness the power of the wind and the sun, and even split atoms. Yet each of these methods come with their own set of limitations. Fossil fuels are finite and damaging to our environment. Wind and solar are dependent on weather conditions, and nuclear power, while efficient, carries the risk of disastrous consequences in the event of a malfunction. But what if we could tap into a resource so vast and so constant that it could theoretically provide us with an unlimited supply of energy? Enter the cold, dark, and seemingly infinite expanse of deep space. A thermodynamic resource that's always available regardless of the time of day or the weather conditions back on Earth. Now you might be wondering, how can coldness generate power? It's a valid question. After all, we're more accustomed to associating power generation with heat, not cold. But it's all about the contrast in temperatures and a little something called the Seebeck effect. The Seebeck effect describes how a voltage difference can be induced by a temperature differential across a material. If we can create a system that maintains a significant temperature difference between the coldness of deep space and our warm earthly environment, we could tap into this temperature differential to generate electricity. The concept is as chilling as it is fascinating. Imagine a material that can cool itself below the temperature of its surroundings, even in direct sunlight, by radiating its heat out into the cold abyss of space. And then, using a thermoelectric generator, we could capture this temperature difference as electricity. Imagine a world where the deep, icy void of space powers our homes, cities, and even our coffee machines. But before we get too carried away, it's important to note that this technology is still in its infancy, and there are many challenges to overcome before it becomes a reality. But it's a chilling thought, isn't it? Scene script. Sounds like a science fiction movie, right? But the science behind it is as real as the air you're breathing right now. To understand how we can generate power from the coldness of deep space, we need to dive into a bit of science. Specifically the role of radiation in heat transfer and the Seebeck effect. Now don't worry, I promise not to make it too complex. Radiation is a process of heat transfer that doesn't require any medium. It's how the sun's heat reaches us here on Earth. And it's not just a one-way street. The Earth is also radiating heat back into space, and it's this outgoing radiation that we can harness to generate electricity. But how do we capture this energy? Enter the Seebeck effect. Named after the German physicist Thomas Johann Seebeck, this phenomenon describes how a material can develop a voltage difference, or in simpler terms, an electric current, in response to a temperature differential across it. So imagine this. You have a material that's warmer on one side, thanks to the ambient temperature of our planet, and colder on the other side, facing the cold vastness of space. This temperature difference can create an electric current within the material, but we're not stopping there. We can take this current and feed it into a thermoelectric generator. A thermoelectric generator is a device that converts heat difference directly into electricity. So essentially, we're using the temperature difference between the warmth of our planet and the cold of space to generate electricity. But of course it's not as simple as sticking a material into space and waiting for the magic to happen. We need a special kind of material called a wavelength selective emitter that can radiate heat at a specific wavelength within the atmospheric transmission window. This creates a cold reservoir that can be used to generate power. So in essence, we're talking about turning the temperature difference between the cold of space and our warm planet into electricity. Cool, right? Now you might be asking, how can we possibly capture this temperature difference? Well, the answer lies in a very special material. This isn't your ordinary run-of-the-mill substance. It's developed with the mind-boggling ability to efficiently channel heat towards the icy void of deep space, while simultaneously blocking heat from the sun and our environment. Imagine this, even under the scorching sun, this material manages to cool itself below the temperature of its surroundings. Quite a feat, isn't it? Now let's delve a little deeper. How does this material work its magic? It all comes down to the principle of radiation. In the grand scheme of heat transfer, radiation is the unsung hero, tirelessly working to balance the temperature scales. This material, our champion, harnesses the power of outgoing radiation from Earth to deep space, transforming it into a source of sustainable energy. This isn't a one-trick wonder, though. The material's unique properties extend beyond radiation and into the realm of wavelength selectivity. It serves as a wavelength-selective emitter, radiating heat at a specific wavelength that aligns perfectly with the atmospheric transmission window. By doing so, it creates a cold reservoir, a pocket of space cooler than its surroundings. There's more. This emitter doesn't work alone. It teams up with a thermoelectric generator, a device that captures the temperature difference between the coldness of deep space and our ambient environment, converting it into electricity. The result? A dynamic duo that's ready to revolutionize the way we generate power. We're not quite there yet, but the potential is enormous. Imagine solar panels that work at night, remote sensors powered by the chill of space, and a world where we tap into the cold, dark depths of the universe for energy. It's not just science fiction, it's a glimpse into the future of energy generation. This material is our ticket to a future powered by the coldness of space. So what might a future powered by the coldness of space look like? Imagine a world where our buildings are cooled, not by energy-guzzling air conditioning systems, but by the infinite chill of the cosmos. Picture skyscrapers, malls, and residential homes, all drawing on the temperature difference between our buzzing planet and the serene cold of space. The heat is sent out into the void, and the coolness seeps in, reducing our reliance on traditional energy sources. But the applications don't stop there. This technology also has the potential to power remote sensors. These devices, often placed in inaccessible or hazardous locations, require a power source that's reliable and self-sustaining. What better than the endless cold of space? It's a solution that's as innovative as it is practical. And then, there's the night owl of renewable energy. Solar panels that work when the sun goes down. Yes, you heard that right. By harnessing the temperature differential between the chill of space and the warmth of the Earth, we can generate electricity even under the cover of darkness. Solar panels that work around the clock. Now there's a bright idea. Now you might be wondering, this all sounds great, but when can we expect to see this technology in action? Well, the reality is we're not quite there yet. The science is sound, the potential is vast, but the practical application is still in its infancy. There are hurdles to overcome, materials to perfect, and systems to optimize. But every great journey begins with a single step, and the first steps have already been taken. Though we may not be there yet, the potential of this technology is as vast as space itself. So, there you have it, folks. We've taken a journey from a chilling thought, ventured into the complex science behind the cold, delved into the material world, and envisioned a future of cold power. What an adventure it has been. We've learned that the coldness of deep space isn't just a vast, empty void, but a potential thermodynamic resource. A resource that could one day cool our buildings and generate electricity. Can you imagine? We could turn the chill of the cosmos into a power source right here on Earth. At the heart of this concept is a material that does something remarkable. It sends heat out into the coldness of space, while shielding itself from the heat of the sun and the environment. It's a bit like a superhero, with the power to cool itself below the temperature of its surroundings, even in direct sunlight. This impressive material works in conjunction with the Seebeck effect, a principle that describes how a temperature difference across a material can produce a voltage difference. Using a thermoelectric generator, the temperature difference between the coldness of space and our warm Earth could be captured as electricity. But it's not just about the material or the science, it's about the future. This technology is still in the works. It's an innovative solution that's not quite ready for prime time, but the potential is out there. It could enable solar panels that work at night and power remote sensors. So, as we wrap up, remember this. The next big thing in energy might not come from the heat of the sun, but from the cold of deep space. It's a revolutionary idea, and it's as exciting as it is innovative. Next time you gaze up at the night sky, remember, the power of the future might just be hiding in the cold, dark expanse of space. Please remember to like, subscribe, and share to keep seeing more of these awe-inspiring videos. Thank you very much from all of us here at Rogo's Daily Facts.